Hi, I'm Jadip Sai. I'm from CSEB section, and the topic which I have selected for this concept video is Explain tree sort algorithm and implementation in Python. Tree sort. Tree sort is a sorting algorithm that is based on binary search tree data structure. It first creates a binary search tree from the elements of the input list or array, and then performs an in-order traversal on the created binary search tree to get the elements in sorted order. So this tree sort is a sorting algorithm that is based on the binary search tree data structure. Binary search tree is a data structure concept where we store the elements in the form of list of array and perform an in-order traversal. We perform the in-order traversal where we have left child are printed first, and then the root element is printed, and then right child is printed. So this is the concept of in-order traversal of the binary search tree. We perform this in-order traversal in binary search tree for getting the sorted order of the array or a list by using the sorting tree. What is binary search tree? A binary search tree is a node-based binary tree data structure which has the following properties. The binary search tree will have these following properties. The left subtree of a node contains only nodes with keys lesser than the node's key. The right subtree of a node contains only nodes with keys greater than node's key. The key and right subtree each must also be a binary search tree. There must be no duplicate nodes. So these are the rules for a binary search tree to exist. So in a binary search tree, there will be a node element. So to that node, we have a left subtree and right subtree. Generally, it should have the left subtree should contain the elements. All the elements should be less than the root node, and all the subtrees, which are all the elements of the right subtree, should be greater than the root node. And another condition is the left and right subtree each must also be in the binary search tree. So these left and right subtrees must also be present in the binary search tree. There must be no duplicate nodes. In the binary search tree, there should not be any duplicate nodes. Duplicate nodes cannot be contained in a binary search tree. If it contains any duplicate nodes, then it is not called as a binary search tree. So these are the rules to make a binary search tree. These are the rules for constructing a binary search tree. So here is an example for the binary search tree. Here we can see 8 is a root node. It is a tree which is in the form of binary search tree. Here 8 is a root node, and here we have left subtree, and here we have a right subtree. As we discussed before, the left subtree of a root node should be always lesser than root node, and all the elements which are present at the right subtree of a root node should be always greater than the root node. And we have also discussed that any duplicate elements cannot be present in a tree. So as we see, here 8 is a root node, and in the left subtree we have 3, which is a left child of the root node, and 10 is the right child of root node, and the left child is less than root node, and right child is greater than root node, and 3 has left child as 1 and right child as 6. So 6 is also a root node now. It is also a node which has left child as 4 and right child as 7. So we can notice that here 6 has the left child which is less than 6 as a 4, and 6 has the 7 as its right child, and the 7 is greater than 6. So it satisfies the condition of the binary search tree. And now coming to the right of the root node, right? So we are discussing about the right subtree of the root node. Here The right node of the root node is 10. The 10 is now the root, now the node, and which has the right child as 14. We notice that 14 is greater than 10 as it is a right child of 10. It also satisfies the condition of the binary search tree. And now the 14 is the root node for 13. The 13 is the left child of the 14. And we can see that 13 is less than 14. As a result, the left child of 14 is 13, which is less than the root node, which is 14. So it also kind of satisfies the condition of the binary search tree. So let's discuss about the tree sort. How to search a key in given binary tree. Let's discuss how to search a key or any number in a binary tree. For searching a value, if we had to a sorted array, we could have performed a binary search. Let's say we want to search a number in an array. In binary search, we first define the complete list as out search space. The number can exist only within the search space. Now we compare the number to be sorted or the element to be searched within the middle element, that is median of the search space, and if the record being searched is less than the middle element, we go searching in the left half, else we go searching in the right half. In case of the equality, we have found the element. So now we have to discuss about the binary search tree. Binary search tree is the combination of the binary tree and searching and the in-order traversal of a binary tree. The binary search tree is the combination of both the binary tree and in-order traversal method. We know that in the binary tree, we are taking a sorted list or a sorted array of numbers, and if we want to find any number which we can name as a key, and we want to find the key in the list of its sorted numbers, then first we are checking the middle element of the array. So for checking the middle element, we are making the average of the first element and last index of an array, and we are finding the middle index of the array. So we are checking the condition for the index middle element while comparing with the key. If the middle element is equal to key, then we are the number which we are searching we have found in the middle index. And the condition is if the middle element is greater than the key, then we have to traverse the left part of from the middle index, the starting to the middle index to be searched again. Or else if the middle element is greater than or the middle element is less than the key which we are searching, then we have to traverse from the middle element to the end of the array. This is about the binary search. In binary search, we start with the n elements in the search space, and if the middle element is not the element that we are looking for, we reduce the search space to n by 2. We keep reducing the search space until we either find the record that we are looking for or we get only one element in search space and be done with while reducing reduction. We are searching n elements of the array which are in sorted order. We are selecting a key element which we are searching in the array. After selecting a key element, we are finding the middle element of the list of the array. We can find the middle element by using the average of the first index and last index. We will get the middle index and we can find the number which is present in the middle index. Now we are comparing the middle index with the key value. If the middle index number is equal to the key, then we have found that number in the array. So simply we will print the index of the array and the value. or else if the middle index element is greater than the key value, then we have to traverse from the starting index of the array to the middle element till we find the element, the key element. Or if the key element is less than the middle, if the middle element is less than the key element, then we have to traverse from the middle index of the array to the end of the array. And we have to search for the key element in that array. Still, we are not able to find the key element in the array, then the key element is not present in the array. So we are printing that the number is not found. It is about the binary search algorithm. The algorithm for the tree sort is: step 1. Take the elements input in an array. Step 2. Create a binary search tree by inserting data items from the array into the binary search tree. Step 3. Perform in-order traversal on the tree to get the elements in sorted order. For the tree sort algorithm, the first step is take the elements input in an array. We have to take the elements as a input array, which are in sorted order. And the step 2 is created a binary search tree by inserting data items from the array into the binary search tree. After taking all the elements, input elements in the form of array, we are creating a binary search tree. And by inserting the elements of the array in the form of binary search tree. At last, the third step, to perform in-order traversal on the tree to get the elements in the sorted order. After selecting all the elements from in the form of array, we are creating a binary search tree, and we are inserting all the elements to the binary search tree. We're performing the algorithms, and at last we are performing in-order traversal to get all the elements in a sorted order. Because in order traversal, we have the left child and then root node and then right child. And in order traversal, all the elements are sorted in ascending order. So as a result, all the elements are traversed in a sorted form. For this condition, we are using the in-order traversal. Applications of tree sort. Its most common use is to edit the elements online. So the application of tree sort is, it is most common use to edit the elements online. We are editing the elements online by using this tree sort application, which works on the principles of the binary search tree and the in-order traversal, where we are creating a binary tree and we are performing the in-order traversal of that binary tree, which is also called as binary search tree, to get all the elements in a sorted form. So we are using this application in the edit the elements online. We are using this to edit the elements in the online format. After each installation, a set of objects seen so far is available in structured program. If you use a splay tree as a binary search tree, the resulting algorithm called splay sort has an additional property, that is, it is an adaptive sort, which means working time is faster than big of n log n for virtual inputs. So these are the applications of the tree sort algorithm, where we are performing or we are editing the elements in online method, where we are performing the binary tree, we are creating binary tree and also performing the binary search, and then at last we are performing the in-order traversal to get the tree, all the elements sorted in this tree sort algorithm. And we are using the splay tree as a binary search tree. The resulting algorithm, called as splay sort, has an additional property, that is, it is an adaptive sort, which means working time is faster than big of n log n for virtual inputs. Time complexity of tree sort algorithm is: average case time complexity is big of n log n. The time complexity of the tree sort is big of n log n. Adding one item to a binary search tree on average takes big of log n time. While adding one element into the binary search tree, it takes the time of big of log n time. Therefore, adding n items, it will take big of n log n time. This is about the time complexity of the tree sort algorithm. Let's see the code of the tree sort algorithm. And coming to the worst case time complexity, the worst case is big of n square. The worst case time complexity of the tree sort can be improved using a self-balancing binary search tree like red-black tree, AVL tree. Using self-balancing binary tree sort will take big of n log n time to sort the array in worst case. While the worst case of the tree sort algorithm is big of n squared, but we can reduce this time of the worst complexity by using a self-balanced binary search tree like red-black tree, ABL tree. Using self-balancing binary tree sort will take. So while performing the red-black tree or ABL tree, the tree sort algorithm will take the worst case of n log n time, which is less than previous one. This is about the worst case. And the auxiliary space, the space complexity and the space which it occupies is big of n. The tree sort algorithm occupies the space of big of n. Let's see the code for this program to perform the tree sort algorithm by using the binary search tree algorithm and also the in-order traversal of the binary search tree. So here is a Python program for the tree sort algorithm. Python 3 program to implement tree sort class containing left and right child of current node and key value. Here we are creating a class which is named node. We are creating a node of a class node, and here we are using the constructor, init constructor, where the item default value of the item is equal to 0, and here the item is passed as a parameter for the class node, and the key self.key value is item. So the key is equal to item and self.left and self.right is equal to none. We are initializing the left and right childs of a node with the values as none while creating a class with the default constructor init method. And we are creating root equal to node of parenthesis. And we are creating a root. We are making a root as a node. And root value is equal to none. The root is storing no value. As a result, the root is equal to none. And we have insert method. This method mainly calls insert rec. So here we have def insert of key. This insert function will take the parameter as key, where global root. We are accessing the outer root value in the function by using the keyword global root. Root equal to insert rec of root comma key. And we have created another function def insert rec with the two parameters root and key. It will take two parameters as root and key. If root equal to none, then root equal to node of key. So at first, if the root value is equal to none, the default value is equal to none, then it will create root equal to node of none, node of key. The first node will be a key. And returning key, returning the root. And if the key less than root of root dot key, root dot left equal to insert rec of root dot left comma key. So if the key value is less than root value, then we are inserting it as a left child of root by making root dot left equal to insert rec of root dot left comma key. We are inserting the left child by using the function insert rec. And if the condition is the key is greater than root dot key, if the key value is greater than root value, then it should be the right child of the key, the root. So as a result, we are creating the root dot right is equal to insert rec of root dot right comma key. So we are passing two parameters to the insert rec, that is the right child and the key value and the value of the right child. We are making it as a right child of the root. And at last we are returning the root. And we have created another function for the in-order traversal. So the function name is in-order rec, which will take the root value as its parameter. It's taking only one parameter. So if the root not equal to none, that means if the binary search tree exists, then it will follow the statements. If the condition is satisfied, then in order rec of root dot left. This in order root dot left is root dot key. The root dot left in the left child will be printed. Then again in order root of right. And again the root value is printed. Then right value is printed. As we know that in order traversal, we are printing first the left child of a node, and then the root node is printed, then the right child is printed. So in this method, we are creating in order traversal, where if the root is not equal to none, which means that the binary tree is created, then only the in order traversal can be performed. So first we are recursing the function in order by making the root dot left. So as a result, all the left elements are printed first. Then again, we are printing the root dot key value. So we are printing the key value. Then again, we are traversing the right subtree. As a result, the right childs are printed. So it makes the output as the all the elements are in sorted order. The main reason we are using in order traversal is to make the all the elements in sorted order as we require the sorted tree. So that's why we are using this tree sort algorithm, which uses the binary search tree and the in order traversal to give the output as a sorted elements of the tree. We are using this algorithm, and we have created another function def tree ins of array. For I in range of length of array, insert array of I. We are inserting all the elements to the tree by using this simple function, which is tree_ins. So we here we have created an array which is equal to 5, 4, 7, 2, 11. So the root node is 5 here, and the 4 will be the left child of the 5, and 7 will be the right child of 5, and 2 will be the left child of 5, and it will also be the left child of 4, and the 11 will be the right child of 5 as it's greater than 5. So it will traverse right side, and it will again check for the condition with the 7, and 11 is greater than 7. So it will be the right child of 7. As a result, all the elements which are left to the root node are less than root node, and all the elements which are right to the root node are greater than root node. So at last we are calling the in order rec of root. So the output will be, as we want the output will be in the sorted order, that is ascending order. The output we are printing as 2, 4, 5, 7, 11, which is the ascending order of all the elements of the tree. So by performing this tree sort algorithm, we can print all the elements, or we can traverse the tree in a sorted order. That is, we can perform the ascending order of the tree traversal. So in this tree sort algorithm, we use the concept of binary search tree and in-order traversal. And in binary search tree, it mainly depends on it will follow the binary search and the binary tree. The binary search tree follows the algorithm. There are two algorithms which are followed by binary search tree. They are binary tree and binary search. As a result, we are creating a binary search tree, and at last to print all the values in ascending order, that is in sorted order, we are performing the in-order traversal. I thank the faculty and college for providing me this opportunity to speak on the topic which is assigned to me in this concept video. Thank you.